Okay, essentially for 12.1 we were looking at power rule. Okay, so just to recap again, if you're given things like maybe y equals to 3x to the power of negative 3 over 2, okay, what will dy over dx be? Let's look at a person. Finding. Sorry, negative what? Morning. Sorry, say again. Negative 9 over 2. Okay. And then x to the power of minus 5 over 2. Thank you very much. Okay. So we have negative 9 over 2, x to the power of negative 5 over 2. The way we actually get this as our answer is, okay, by bringing down the power first. Okay, then after that, the power of x we need to minus 1. So we get negative 5 over 2 in the power. And then the coefficient will be negative 9 over 2. Okay, now what if, okay, the question wants you to express it into a positive index form. Okay, so in this case, our power itself is a negative number. If I want to express it in a positive index form, okay, which is usually the case, we have negative 9 over 2, okay. This x over here, we need to bring it down to the denominator, and I have x to the power of 5 over 2, okay. Then maybe just to also recap about your rational indices, okay. The power of x, which is 5 over 2, denominator being 2 means that it is a square root, okay, and the numerator being a 5 means that we are looking at x to the power of 5 and then a square root, okay. So I'm making use of this question over here to really recap certain things about your indices, okay, and then also the power rule as well, okay. I think that when it comes to applying power rule, you all can do it, okay, but indices wise, I think you all may need to strengthen that part a little bit, okay. So last lesson, okay, we actually covered one example of gradient application to differentiation. So let's look at another example. I want us to look at exercise 12.1, question 7. Of each curve at the given point. Okay, so this curve that we have is y equals to x minus 1 times 2x plus 3 over x, and at the point x equals to negative 2. Let me write this one. Okay, what will your first step actually be, Hui Jia? What will your first step be? We want to find gradient, means we need to find dy over dx. But before that, we need to prepare some work first in order to find the derivative. Oh, expand this one. Okay, great. So we expand this. The numerator we get 2x squared plus 3x minus 2x minus 3 over x. Numerator simplifies to this. Okay, then what next? Expand already. Is this good enough for us to differentiate? Make sense? Can we differentiate already? Do you know how to differentiate this? No, right? So what else? What other things could we do with this thing? Everything divided by x. So I need to break it down. Okay, so I'll get 2x plus 1 minus 3 over x. And then very importantly, for the 3 over x, I will re-express it as 3x to the power of negative 1. Okay? So that then, now I can apply my power rule. Okay, to find out what is our first derivative, So what would we get? Jingxuan? 2 okay. Times 1. X to the power 0, okay. Plus 0 minus 3 times negative 1. X to the power negative 2. Very good. Okay. So teacher has given us really the full breakdown, okay, over how we actually have to bring down the power of x. In this case, for this x, the power is 1. So brought it down. So 2 times 1. 1 minus 1 gives us 0. For constant number 1, okay, it actually differentiates to be 0. Then after that, this power negative 1 here bring down. So negative 3 times negative 1, power minus 1. Okay, so we simplify it, we get 2 plus 3x to the power negative 2. In other words, I can write it this way as well. Okay? So, in this question, it doesn't matter which form you give it to give the answer as, because the question wants us to find gradient. So we're not done yet. Okay? To find the gradient, we are given the x value already. So we need to place it inside our dy over dx. Find out that the gradient, okay, will be computed as such. Pressing this into our calculator, we will get 2 and 3 over 4. Okay. Right, any questions? Yeah. So what's important when it comes to finding the gradient is that because we're always differentiating with respect to x, right? Okay, I need to know the corresponding x value in order to substitute to find the gradient. Okay, if I'm given the y coordinate itself, I need to go and find the x coordinate from the given equation here first. Okay, then I can use the x value to find the gradient. Okay, so if given y value, there's an additional step involved. Okay. Okay. Next, we look at exercise 12.1, question 11. We have to work backwards in this question. We are given the equation of the curve, which is y equals to x cubed plus px plus q. The gradient at the point 316 is 20. We need to find the constant value p and q. Okay, so when given our y equals to x cubed plus px plus q, we first differentiate it to find out, okay, what is the expression for our gradient. Okay. And what would we get in this case? Amelia Ng. Sorry, I cannot differentiate the Ng and the Ho. Which one is Ng? You, okay. What do we get for our differentiation? 3x squared plus p. Anything else? No, okay. So p and q are just numbers. Okay, so px differentiate to be p. Okay. Then now we can make use of this information. At 316, gradient is 20. So that means that when x is equals to 3, our gradient equals to 20. Okay, that will help us to find out the value of p. So this is 27. 1, right? Is it? It's Shah's voice on. Okay, so we get P equals to -7. Okay? Okay, so after getting P equals to -7 already, we need to find Q still. Okay, so how would we go about finding the value of Q? Wait, can you propose something? How do we find the value of Q? I have already found P. Sorry? I will hear P then. Sub P back into the equation and then the 316 also sub inside. Yes, okay. So we make use of this point because this point is found on the curve itself. Okay, so that means that we are looking at y equals to x cubed minus 7x plus q. So then at 316, we have y equals to 16, x equals to 3. Okay, and then we can solve. And q equals to 10. Okay, next part 2. You want to find the coordinates of the other point. On the curve where gradient is 20. Okay, so since we have already found out what is P and Q, that means that our equation is y equals to x cubed minus 7x plus 10. In other words, my dy over dx is 3x squared plus, minus 7. Right? Okay, so we want the other point on the curve itself that has that same gradient. So that means that we are trying to solve 3x squared minus 7 equals to 20. Okay? How would you want to go about solving 3x squared minus 7 equals to 20? Okay? How many of you would actually shift the 20 over? So option 1, okay, minus 7 minus 20. How many of you would actually end up doing this and then use your quadratic formula? That means you use x equals to this formula. How many of you would do this? Okay, then what about the rest? Joshua, what will you do in terms of solving this one? Will you do in this manner also? I want to find x. This is correct, nothing wrong with this, but my question is just, would you do this? You okay? I mean, this way of solving is fine, right? Because it's quadratic. Okay, so we just need to recognize your A to be 3, B is 0, C is negative 27. Okay, nothing wrong with that. So maybe just let me write that out first. Okay, C is negative 27 over 2, 3. Okay, why I ask this is that, okay, we notice that there is no coefficient of B. Actually, another way of solving for this question, okay, is that we can do 3x squared equals to 20 plus 7, that is 27. And then we can solve x squared equals to 9. I would definitely find this easier than to do this, but either way is fine, okay? I want us to be flexible, okay, in knowing what are the options that we can take in solving, right? Don't be so dead on every time quadratic is like formula, okay? So this one can also do like that. Okay, so x will actually become 3 or negative 3. Just have to take note of that. Likewise, this will also give us two answers. 3 or negative 3. Okay? Then with 3 or negative 3, since we already know 316 as one of the set of coordinates that gives us gradient 20, that means that the other point will have to be negative 3. So if I were to continue here, when x equals to negative 3, y would be equals to negative 3 cubed minus 7 negative 3 plus 10. Okay, and that value is going to be 4. So therefore the coordinate is negative 3. Okay. Questions? Okay. I'm just thinking, okay, for discussion. Alright, we are done with chapter 12.1 already. Okay, exercise 12.1. Okay, I could give you a homework. Alright, that will mean that tomorrow you must do it on top of the assignment I'm going to give you for home-based learning. Okay, so tomorrow my plan is to let you all go through product rule lah. Okay, that's 12.3. Alright, then Friday I need the homework to be returned to me so that I have the weekend to mark and then I can return it to you on Monday. Our WA is on Wednesday, so that's option 1, do homework. Okay, and then still got product rule to cover tomorrow. Okay. Second option, okay, I let you know the homework questions. You can take that as a practice. I'll still upload the solutions. You mark on your own. Okay, what I will mark instead is that Friday, come back, okay, I'll give you a very short quiz. Okay, it's just a 9-mark quiz itself, okay, about 15 minutes to actually cover power rule as well as our chain rule. Okay, that one I will mark, then I will return it to you. Actually, that one just 4 questions. Okay, the quiz is just 4 questions. Alright, so what options do you all want to take? I mark your homework or I mark the quiz? I mark quiz. Okay, I also think so. Okay, so if that's the case, right? Okay, then Friday we will have a quiz. Okay, that will cover this and then also our chain rule coming next. Okay, so my intended homework questions that I want you to practice, okay, is this one. You go and practice on your own. Okay, I will upload the solutions. If you have questions regarding this, you can always just drop me a text or an email. Okay, 4B, 4D, 5B, 6C, 6E, 6F, 8 and 9. Okay, so this one, own time, own target, OT, OT. Okay. Alright, next we move on to chain rule. Chain rule is slightly complicated. Once you get the hang of it, you'll be fine. Okay, for chain rule, right, what we're trying to achieve, okay, in applying this rule itself is to know how to actually differentiate things like, for example, 2x squared plus 3x to the power of 10. Okay, at this stage, based on what we have already covered, okay, what we can only do is to expand the entire thing and then slowly term by term differentiate. Okay, to expand this itself from binomial theorem, we already know that it's going to be very tedious. Okay, so not going to be feasible, not practical as well. That's why we have this thing called the chain rule. Okay, how is it a chain rule? Let me tell you how to actually differentiate first. Okay, similar to our power rule. Okay, this power bring down, then the power minus 1. Okay, So we look at the bigger picture, then we look into the smaller things inside the brackets. You understand that? That's why it's called a chain rule, okay? Chaining effect, right? So bring down power minus 1, differentiate inside. Okay, very often people tend to forget the differentiation of inside. Okay, and everything is being changed by multiplication. Okay, all product. Alright. Then you can leave your answer like this. Okay, is it in its factorized form? Okay, you need not actually leave your answer as 40x plus 30. Okay, and then 2x squared plus 3x to the power of 9. Okay, you need not do this. It's perfectly fine if you just leave it factorized. Just at the power, remember to simplify it to 9. Okay? So, power breakdown. Power minus 1. Then differentiate inside. Write it out very clearly, the entire algebraic generic form and all that. But I really don't see the point in trying to remember all those kind of form. We just need to get a routine going in terms of power breakdown, power minus 1, differentiate inside. Okay, that's all we really need to get it going. Right, so that's actually the try 6 question. Okay, so we look at try 7. Into try 7 part A. Given y equals to 1 over 5x minus 1 to the power of 3, same thing as our power rule, we must always bring this up into the numerator first. So we will have 5x minus 1 to the power of negative 3 before I can apply my chain rule. So this is a critical step. Okay, then dy over dx will actually be power bring down power minus 1, differentiate the inside. Okay, this one you must simplify. Negative 3 times 5, we get negative 15. And we have this. For half an hour already, I think it's time to wake up. Okay. Right, why you're laughing? Just consider. Or is it more than half an hour already? Since the last period, is it? No. Okay, let's look at part B. Part B, we have y equals to square root 7x squared plus 6. Okay, so same thing, we express this into its power of half, then we differentiate, power bring down, power minus 1, and then differentiate inside. Okay, but then the next thing is about simplification. Okay, so simplification wise, we are looking at half times this thing times 14x. In other words, it's also the same as half times 14x times this thing. Okay, so half times 14x gives us 7x. Okay, 7x squared plus 16 to the power of negative half. Usually, okay, you will be asked or rather expected to actually put it into positive index form. So half is square root, negative in the denominator. Okay, the inside of the square root will be 7x squared plus 16. Yep. Oh, 6 huh? Oh, sorry. Thank you. Is that all? Yes. Okay. Questions? Right? I want you to familiarize yourself with the power rule. So, I want you to do now question exercise 12.2. Okay. This is in textbook page 14. Question 1A, 1C, 1E, 2B, 2C, 2F, 3B, 3D, 4. Okay? This kind of thing must practice one. Okay, do now. If you're still not familiar, raise your hand, I'll come to you, okay? Give you 20 minutes to do all this question, huh? Are we done? Not yet. Any questions that you want to clarify? Okay. Apologies that some of your classmates may not have the best handwriting on the whiteboard or the best size of handwriting. Okay. Okay, but generally, I think the classmates have definitely showed as clear as possible the working that's required. Okay, for you to understand the idea of power bringing down, power minus 1 inside differentiate. Okay. Right. I just want to maybe point out different ways of presentation. Okay. At the beginning, as I walked around, I saw some of you forgetting to let y equals to something. Okay, then after that, you just directly, like what Jovian did in this earlier working, he immediately gave y equals to this. And this doesn't make sense because this is y and this is dy over dx. They cannot possibly be equal. Okay, how can x plus 3 to the power of 6 suddenly become 6 times x plus 3 to the power of 5? We clearly know that they mean different things. Okay, so that's why, okay, presentation wise is very important. Okay, whereas for Glenys, what she did in a different way of presentation is that, okay, she decided not to let y equals to something. She directly applied d over dx as an operator, okay, to your 5 minus 4x squared to the power of 6. So putting d over dx in the front, that is good enough as well. Okay. So those are the things that I pointed out at the beginning of the differentiation chapter lah. Okay. So, but of course, this also depends on question by question. Sometimes y is already defined or things have been defined as fx. Okay, then we might need to use suitable notations, okay, to our presentation. Right? Let's move on. Okay, let's look at exercise 12.2, question 5. Right, I'll erase this part here. Okay, I think we get the idea already. of the curve at the point where y equals to 1. So this is exactly what I was trying to mention earlier on. Okay, so given y equals to 1 over 3x minus 2, what is the first thing that you will do first? Let's pick someone, ellipsis. What will you do first? What will you do first to answer this question where we want to find the gradient? Minus 2 to the power of 2. Negative 2. Negative 2 or negative 1? Negative 1, okay. So power of negative 1, yeah? Right? So from the denominator, bring it up into the numerator, okay, it becomes a negative. Okay, in this case, 3x minus 2 is actually secretly a power of 1. So bringing it up will be a negative 1. Okay? So next then we can go about differentiating. So bring down the power of negative 1. Keep it the same thing, power minus 1, so we get negative 2. Differentiating the inside of the bracket of 3x minus 2, we get 3 itself. So the derivative is negative 3 times 3x minus 2 to the power of negative 2. You can leave it in this form, or you want to bring the 3x minus 2 into the denominator. That's also fine as well. Okay, they are the same, but that's not the objective of the question. Okay, objective of the question is to find out the gradient when y is equals to 1. Okay. Given y equals to 1, I cannot substitute into my dy over dx because my dy over dx is in terms of x. So what I need to do is to find out what is the corresponding x value when y equals to 1 in this graph itself. So an additional step is required when y equals to 1. We have 3x minus 2 equals to 1 upon cross multiplication. And we find that x will be equals to 1. Then I make use of this x value, find the gradient. And that gradient would be negative 3. Okay. And look at question 6a. We have x plus 2 square times x plus 2 square root. Okay, we have not yet learned the product rule, which we'll learn in the next section. Okay, in this case, there's not much need for us to use the product rule. In fact, I want us to notice that x plus 2 is a common base, okay, in this part of the expression and in this part of the expression. Okay, which leads us to actually see that x plus 2 square root is the same as x plus 2 to the power of half. Okay, that's the first observation we must be able to make. Right? Since the bases are actually the same, by our laws of indices, okay, I can combine it into a single base, and then my power can add together, right? Okay, so my y is none other than just x plus 2 to the power of 2 plus half. Usually we write our powers in irrational number form. That will be 5 over 2. Okay, so we need to set this up first before proceeding with differentiation. x plus 2, we get 1. So 5 over 2 minus 1, that will give us 3 over 2. Okay. It is okay for us to leave our answer like that. But then, not all the time, okay, it is open. Sometimes in the question, they will expect you to express it in a certain form. So I want us to know that having a power of 3 over 2 is the same as the denominator being 2 is the square root of x plus 2. And then the numerator being a 3 means that x plus 3 is to the power of 3. Okay? So I'm reinforcing your indices laws over here about your fractional powers. Okay? I also, on the side, I want you to be able to recognize the equivalence. It is the same as writing x plus 2 square root then to the power of 3. Okay, so your power of 3 you put inside the square root or outside. They are the same, okay? So all these 3, they mean the same thing. Okay? Okay, I can see that Chloe is having frustration that today's lesson is 1 hour 20 minutes. Looking at the clock already, still got 20 minutes more to go. Okay, I just have 2 more questions. Okay, then we're done for the day. Okay, and done for this 12 point course. Okay, next one. Question 7. Okay, this one. Okay, this is a question I want to make use of to recap our partial fractions last year. Okay, so we have x over x plus 1 and we want to show that it is 1 minus 1 over x plus 1. Okay, so you need to recognize that the question is asking us to do partial fractions. Okay, the numerator is a polynomial of degree 1 because the highest power is only 1. Okay, so this is a degree 1 polynomial. This one is also degree 1 polynomial because the highest power of x is also 1. When the degrees are actually the same in both numerator and denominator, the fraction is improper. Okay? For improper fraction, what must we do? What must we do for improper fraction? When we want to break it into partial fraction? You see, forget already. We must do long division. Okay? So improper fraction must do long division. X is inside, x plus 1 outside. Okay, because x divided by x plus 1. Okay? So with x and x over here, I only need to times the 1. So that 1 times x plus 1, I will get x plus 1 minus negative 1. Okay? We stop our long division when this expression over here has a degree that's lesser than this. Okay? So it's not long division when the degree here, which is now 0, okay, so degree 0, is less than this x plus 1 degree, which is degree 1. Okay, so it's actually a very short long division. So it's not quite called long division after all. Okay, then now using our long division, we re-express it into an answer. Okay, so Actually, our 1 is over here, minus away 1 over x plus 1. Exactly what the question wanted. I'm just slowly dropping in all this long division and all that, okay? Because once we reach integration, which is a few chapters away, you must know your long division and your partial fraction rate. Okay? That's why those that come for A-Maths remedial last year, end of the year, we covered polynomials as a chapter. Okay? Okay, so let's look at part 2. Part 2 wants us to hence find the derivative of x over x plus 1. Okay, so because it says hence, and clearly at this juncture we don't know how to differentiate this. Okay, because even if you rephrase your x over x plus 1 into x times x plus 1 to the power of negative 1, even written in this form, at this juncture we don't have the skill to do it. Okay? So the only way to get around it is to make use of the partial fraction, which is 1 minus 1 over x plus 1. Okay? I'm only currently trying to simplify the question itself. I'm not yet differentiating. That's why the differentiating operator still maintains here. Okay? We have 1 minus x plus 1 to the power of negative 1. Okay, then now I can go about applying my power rule and my chain rule. Differentiate 1 is 0. Differentiate negative x plus 1 to the power of negative 1 is negative. Power bring down negative 1. X plus 1, power minus 1. Differentiate x plus 1 is 1. Okay? Then simplify negative, negative, positive. X plus 1 to the power negative 2. Same idea as 1 over x plus 2, x plus 1 to the power of 2. Okay? Questions? One last one that we can call it a day. And with it being the last question, we go for the hardest one. Okay? Challenge ourselves. Okay, so we have y equals to 1 over 4 minus square root 16 minus x squared, then the whole thing square. So we must get our foundation right. Always, okay, the x whatever must be the numerator. So we always set that up first. So this one, move up. Our power of 2 will have to change into power of negative. Okay? Then maybe your square root, you want to actually re-express it into a power first. That is power of half. Okay? So we get all this clearly stated out. But of course, if you are very good in your indices, okay, and you don't want to write down such so clearly, it's fine. Alright? that you want to jump straight into differentiating. Okay, so now let's differentiate. Okay, so the entire square bracket is the 1 to the power of negative 2. We bring down the negative 2. Everything else in the square bracket remains the same. Then power minus 1. Okay? Maybe let me squeeze things to the left a little bit, sorry. dy dx. Okay? Now we need to differentiate inside the square brackets as per our chain rule. Okay? Differentiate this thing inside here. So differentiating 4 is 0. Let me intentionally just write it as 0. Okay? Then minus away. This thing over here, okay, needs to be differentiated. How? By chain rule again. Okay? So by chain rule again. So this is a minus, the power bring down. So minus half. 16 minus x squared. Power minus 1. Okay? 16 minus x squared need to differentiate again. Let me erase this heading. Okay? 16 minus x squared differentiate again, we will get 0 minus 2x. Right? So, differentiation of this entire curly line thing is found here. Okay? Then we use a green marker. This thing that I'm using green marker to box up, differentiate using chain rule, we get this thing. Okay? Very annoying, I know. That's the thing about chain rule. If you can't get past this one, then I'm concerned about the next few chapters. Because next few chapters you're going to differentiate trigonometry, exponential, and then your logarithms. Very exciting, right? Okay, so simplify. Then this one, let me just tidy this up. Why did it become minus half? Because down here minus sign, right? Then the power bring down is half. Right. Then half minus 1 is negative half, right? Correct? 50 cents minus $1 is I owe you 50 cents. Huh? You don't get it? What did you not get? Okay. Power half minus 1. Okay. Did I overlook anything? Okay. At this stage, if you leave your answer like that, it's fine. Okay, but I think we want to know how to work with our indices lah, okay? So I want to give you equivalent answers as well. Okay, this is an equivalent answer. I'll give you some time to process this, think about it. Yeah. Understand how I move from here to here. I just erase this coloring, but don't confuse ourselves. Okay, so what I did here is that we observe this entire square bracket is power negative 3. Negative powers means that it goes down into the denominator. So that's why power of 3, okay, for the entire set. Then this is actually multiplication, negative 2 times this thing. Okay, I can also see individually as times x times 60 minus x squared to the power negative half. So negative 2 times x remains in the numerator. 60 minus x squared to the power negative half is the one that goes down to the denominator. Okay, so negative power goes down, half means square root. Okay? Right, so then it was really a test of your indices skills, yeah? Okay, go back and really look into it. Next lesson, on Friday, at the start I will give you a very short quiz. Okay, those that might have missed out, like for example, Sushi, please go and catch up on the video. Okay, then after that, tomorrow's lesson, I will give you product rule to cover. Okay? Alright, that's all. Thank you everyone.